Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hazim bin Zambry, and I will do the presentation on the final year project with the title of Simulation of a Kind of a Thin Wall Tube Crushing Member. First is project summary. This proposal focused on the simulation of thin wall tube when it was crushed. The thin wall column was made from aluminium, undergoes the buckling collapse test to test the yield strength of the structure. The purpose of this experiment to determine the design of a thin wall column with better energy absorption, and it was compared the experiment and simulation result by using finite element analysis FEA and abacus. There will be 5 specimens with different characteristics to gather the data on this project. For introduction, thin wall was used in different variety such as building and bridge construction, automotive industry, aircraft and ship. Thin wall structure are easy to make into many type of cross section compared to the normal structure. Thin wall was used in automotive industry as the energy absorber because of its lightweight and has high energy absorption efficiency. It was also used in construction because it has a great load carrying capacity despite its small thickness. However, this flexibility can lead to complex structure behavior such as several buckling modes or even multiple failure modes. In China, rock explosion incidents in coal mines have become a common occurrence in recent years and have become the biggest mining disaster. The hydraulic safety valve is too late to operate for pressure release protection because the surrounding pressure increased rapidly due to rock burst. This will result in a complete system failure, instability and destruction, as well as equipment damage and casualties. The development type of a hydraulic column with better energy absorption ability and fast dynamic yielding needed to improve the anti-impact ability of roadway hydraulic support equipment. Next is literature review. Different structure model were proposed and simulated for a thin wall cylinder crushing component used in the composite spiral anti-impact device. Yao revealed that as the thickness of the pipe wall and radius of the hole is reduced, the average crushing force decreases. Adachi found that the ribs can improve the energy absorption characteristic, and uniform annular groove can reduce the peak load, make the load pass evenly, and control the folding location. Besides that, when subject to impact stress, the tubular structure display high energy absorption capabilities, resulting in less injury during collision. Moreover, the energy absorption of the beam increased as the wall thickness of the beam increased. According to the prior study, changing the cross-section from circular to corrugated can readily increase the buckling stress. From the previous study, we can see that when we can add a groove around the column to improve the energy absorption and increase the yielding stress. Next is problem statement. Hydraulic column support column is used as the main roadway support for the safety purpose during coal mining. However, the hydraulic support cannot respond quickly for pressure relief protection to open, and this will cause damage to the support, bend the column, and lead to destruction of the entire support system. It shows that the anti-impact performance of the support does not meet the requirement to perform well in construction industry. And this study was designed to analyze the crushing mechanism of thin wall structure. Hence, the objective for the experiment are: first, to improve the performance of energy absorption. Next, finding a way to reduce the peak load and initial crushing strength ability problem. And lastly, to design the collapse structure of a thin wall circular tube. Next is scope and limitation of the project. This experiment will be conducted by using a round tube and hollow tube with 5 different wall thickness, and groove. The study will be conducted in laboratory and all of the sample will undergo collapse buckling test using the microcontroller electronic universal testing machine to find out the deformation of each member. From the experiment, student also gathers data of the initial peak force, energy absorption, and effective deformation yield. Methodology. Student will gather data using two ways, which are through finite element analysis simulation and experiment in laboratory. The sample is designed in CATIA software following the dimension of the actual sample. Then, the design is transferred into finite element analysis to determine the behavior, buckling, deformation, and pressure on the specimen. The result of FEA-based simulation are represented by color scale that illustrate the pressure distribution over the specimen. The result from the laboratory is then being compared with the simulation result. If both of the results show small difference, it can be used for future works and reference. Next is expected result. Finding journal comparisons during literature review and reading process is the expected result for this project. From previous study made by Lin in 2017 stated that by putting number of circular arc groove alternate on the outer wall, inner wall, and outer wall of the thin wall round tube can reduce the peak load and early mini crushing strength stability difficulties. Also, groove can control the folding location, reducing the peak load and make the load pass evenly. It also was found that the ribs can be used to increase energy absorption characteristic. From the diagram above, we can see that a hollow tube with groove have a better energy absorption and yield strength because it has a more green color and blue color compared to the others. Thank you.